Hey everyone, and welcome back for another deep dive. Today we are going to be talking about confidential VMs.
Ooh, exciting.
Yeah, it's a pretty cool topic,
Yeah,
especially, if you care about data privacy in the cloud.
absolutely.
Um, it's kind of like you're putting your data and applications in someone else's hands when you use the cloud.
Yeah, that's a really good way to put it.
Right. So it does raise concerns about who has access and how secure that data really is, even with all the security measures that cloud providers have.
For sure.
It's kind of like trusting someone with your house keys,
Yeah,
right?
yeah.
You hope they're going to be responsible, but there's always that concern, like what if
I never know.
you never know, right?
Exactly.
So that's where confidential VMs come into play.
They do.
They offer like a whole new layer of security for cloud computing.
Yeah, they're essentially virtual machines.
Okay.
But with a super important addition, hardware-based memory encryption.
Hardware-based. Is that different from like the usual software encryption we hear about?
Yeah, it is, and it's a really important difference.
Okay.
So think of it this way. Software encryption protects your data when it's stored, like when you save a file on your computer.
Right.
And when it's traveling across a network, like when you send an email.
Gotcha.
But what about when that data is actually being used, processed, manipulated?
Yeah, that's a good point. I never really thought about that.
It's kind of like locking your front door and setting up a security system, but leaving all your windows wide open.
Okay, that makes sense.
Right.
Yeah.
So that's where hardware-based encryption comes in.
Okay.
With confidential VMs, the data is actually encrypted in the computer's memory.
Wow.
So even if someone gains access to the physical server or the hypervisor.
Hold on. Hypervisor, what's that?
Oh, right. Sorry, the hypervisor. That's basically the software that manages all the virtual machines on a physical server.
Okay.
You can think of it like the landlord of your virtual apartment building in the cloud.
Got it. Okay. So even if the landlord was compromised, the data inside would still be protected.
That's exactly it. That's what makes confidential VMs so amazing. So the encryption keys, they're like the codes to unlock your data. They're generated and stored in a completely separate piece of hardware. It's called a Trusted Platform Module, or TPM.
Okay.
And this TPM is totally inaccessible to the hypervisor or any other software running on the system.
Just like having a separate locked safe within your apartment that even the landlord can't get to.
Exactly. Perfect analogy.
That's really cool.
With confidential VMs, your data is protected at the hardware level, so it stays confidential even if someone gets into the underlying infrastructure.
That's impressive.
Yeah.
Okay, but how do I know as a user that this is all actually working like it's supposed to?
That's a great question, and that's where attestation comes in.
Attestation.
Yeah, it's a process that lets you verify the integrity and authenticity of the whole confidential VM environment.
So it's like a certificate of authenticity proving that the safe hasn't been tampered with.
Exactly. Attestation provides cryptographic evidence that the VM is running on trusted hardware, that the TTM is functioning correctly, and that those encryption keys haven't been compromised.
Okay, so that gives me the assurance that my data is truly protected.
Yep, you got it.
Okay, so we have this hardware-based encryption and this attestation thing,
Right.
making sure that our data is locked up tight.
Yes.
But I imagine there are different ways to achieve this, right?
You're right.
Like, are all confidential VMs created equal?
Good question. There are multiple confidential computing technologies available,
Oh, okay.
and each has its own strengths and weaknesses.
Got it. So it's like choosing different kinds of locks for your safe, depending on what you need.
Exactly.
Okay, so what are some of the options out there?
Well, a popular one is AMD SEV.
AMD SEV.
It stands for AMD Secure Encrypted Virtualization.
Okay.
It's a leading technology, and it's known for being really high performance and having relatively low overhead.
Overhead, what does that mean?
Good question. Overhead refers to the additional resources that a technology needs to work,
Okay,
like processing power and memory.
right.
And in the case of confidential VMs, overhead can impact how well your applications perform. So the lower the overhead, the better.
Got it. So AMD SEV is efficient.
Yes, very.
Okay, so how does it work?
So AMD SEV uses a special component within AMD processors called the secure processor.
Secure processor.
It's like a dedicated security enclave.
Enclave.
Yeah, think of it as a separate, highly secure compartment within the processor itself,
Okay.
designed specifically to handle sensitive operations like encryption and key management.
Oh, so it's like a mini vault inside the processor where all the encryption magic happens.
Exactly. With SEV, the VM's memory is encrypted by the secure processor, and the encryption keys are stored securely within the TPM.
So even if someone gets access to the physical memory, they can't decrypt the data.
That's right.
That's incredible. And you said it has low overhead, so it doesn't slow down my applications much.
Exactly.
Okay, that's great high security without sacrificing speed.
You got it.
Are there any other advantages to using SEV?
Yeah, there are.
Like what?
One of the really cool things is that it supports live migration.
Live migration? What is that?
Yeah. So live migration allows you to move a running VM from one physical server to another without any downtime or interruption to your applications.
Wait, really? So it's like moving an entire apartment building to a different location without the tenants even noticing?
Exactly. That's a great way to visualize it.
That's awesome.
With live migration, you can seamlessly move your VM to a different server for maintenance upgrades or even load balancing, and it won't affect your applications at all.
That's so convenient,
Right.
especially for businesses that need their applications running all the time.
Exactly. And it's worth noting that SEV machines with the N2D machine type, which are specifically designed for high-performance computing, they fully support live migration.
Okay, so we've got robust security, low overhead, and the convenience of live migration with SEV.
That's right.
It sounds like a really good option for protecting sensitive data.
It is.
But are there any other confidential computing technologies we should consider?
There are. If you're looking for even stronger security, especially against really sophisticated attacks that target the hypervisor itself, then you might want to look into AMD SNP.
SEV SNP. What's that? How is it different from the regular SEV?
Okay, so SEV SNP stands for Secure Encrypted Virtualization Secure Nested Paging.
Okay.
It builds upon SEV, but adds an extra layer of protection against malicious hypervisor attacks.
Malicious hypervisor attacks. You mean like if the landlord, in our analogy, went rogue and tried to snoop on the tenants?
Exactly.
Wow.
While regular SEV protects against attacks on the physical memory, SEV SNP goes a step further by safeguarding against attacks that exploit vulnerabilities in the hypervisor itself.
So it's like having a security system specifically to monitor the landlord and make sure they aren't doing anything shady.
Exactly.
Yeah.
SEV SMP adds protection against things like data replay and memory remapping.
Data replay. Memory remapping.
Those are techniques that attackers can use to manipulate or steal data by taking advantage of weaknesses in the hypervisor.
So SEV SMP basically prevents the landlord from using these sneaky tactics to get to my data.
That's right.
Okay, so it's a much stronger level of security.
It is, especially in environments where you need to protect against very sophisticated attackers or where you're worried about the integrity of the hypervisor.
That makes sense, but I'm guessing this extra security comes at a cost, right?
You're right. Again, it does come with higher resource consumption compared to regular SEV.
Higher resource consumption. Does that mean it'll slow down my applications?
It could. You might experience slightly lower network bandwidth and higher latency with SEV SNP.
Okay.
Basically, the enhanced security requires more processing power and memory,
Right.
which can impact performance.
So it's like having a more secure apartment, but the internet isn't as fast.
That's a good way to put it.
Okay, so it's a trade-off I'd have to consider.
Right.
If security is super important, and I don't mind a little performance hit, then SEV SMP makes sense.
Right.
But if performance is my top priority, then maybe regular SEV is a better fit.
Exactly.
Okay, so we've got SEV, which is like a good all-around choice with decent security, good performance, and the convenience of live migration.
Yeah.
Then we've got SEV SNP, which is like the super secure option with maybe a little slower performance.
Yeah.
Are there any other players in this confidential computing world?
Yes. There's one more worth mentioning, and it's pretty unique. Intel TDX, or Intel Trust Domain Extensions.
Intel TDX.
Yeah, think of this one as building a fortress within a fortress.
A fortress within a fortress. Whoa, okay, tell me more.
So with Intel TDX, you're not just encrypting the VM's memory, you're creating an entirely isolated execution environment
Oh, wow.
called a trust domain, or TD, within the VM itself.
So it's like having a secret room inside my already secure apartment.
You got it. This TD is totally isolated within the VM, and it's protected by hardware-based security mechanisms.
Okay.
So even if the hypervisor or other parts of the system are compromised, the data and applications within the TD remain safe.
That sounds super secure. How does it achieve that level of isolation?
It uses a mix of hardware extensions and software components. The hardware extensions are built right into the Intel processors, and they provide the foundation for creating and managing these trust domains.
Got it.
And then the software components work with the hardware to enforce security policies, manage encryption keys, and ensure the integrity of the TD.
So it's like having a team of security guards working with the building's security system to protect my secret room.
Exactly. TDX provides a multi-layered approach to security, making it extremely resistant to even the most sophisticated attacks.
This is amazing. So with TDX, I can create these ultra-secure compartments within my VMs to protect my most sensitive data and applications.
Exactly.
Are there any downsides to using TDX?
Well, like any technology, it has some trade-offs.
Uh,
One thing is it's relatively new compared to SEV and SEV SMP,
Okay,
so it might not be as widely supported across different cloud providers and operating systems yet.
gotcha. So it's like having a state-of-the-art security system, but maybe the installation isn't as straightforward.
Yeah, that's a good way to put it. And another thing to keep in mind is that TDX can have a slightly higher performance impact compared to SEV, especially for certain workloads.
Okay, so it's super secure, but might not be as readily available or as performant as the other options.
Right.
It sounds like choosing the right confidential computing technology is all about finding the right balance between security, performance, and compatibility.
You got it. There's no one-size-fits-all solution.
Right.
It all depends on your specific needs and what your priorities are.
I'm starting to see why this topic is so fascinating.
Yeah.
It's not just about picking a technology. It's about understanding the nuances, the trade-offs, and the bigger picture of how confidential computing is changing cloud security.
Absolutely.
But we've been focusing a lot on the technical details.
Yeah.
I'm curious, how are these confidential VMs actually being used in the real world?
That's a great question.
Like, what kind of applications are they best suited for?
Well, that's where things get really interesting because confidential VMs aren't just some theoretical concept. They're being used today to solve real problems and enable new possibilities across all kinds of industries.
Okay, I'm all ears. Tell me more about how businesses are using these confidential VMs.
One area where they're making a huge impact is in healthcare.
Oh yeah, healthcare data is incredibly sensitive.
It is. You have patient records, medical histories, genetic information, all kinds of data that needs to be protected.
Absolutely. And with more and more healthcare moving to the cloud, the need for strong security measures like confidential VMs becomes even more crucial.
Exactly. Confidential VMs allow healthcare providers to use the cloud for things like data analytics, machine learning, and genomic sequencing,
Wow.
while ensuring that patient privacy remains a top priority.
So, for example, a hospital could use confidential VMs to analyze patient data, to identify trends and improve treatment outcomes without ever exposing that data to unauthorized access.
Exactly. They could run complex algorithms on encrypted patient data within a confidential VM, extracting valuable insights while keeping the data itself completely confidential.
So it's like having a medical researcher who can study patient data without ever actually seeing the patient's identities or personal information.
That's a great way to put it.
Wow, that's amazing.
And it's not just about protecting patient privacy.
Right.
Confidential VMs can also help healthcare providers meet regulatory requirements,
Okay.
like HIPAA in the United States,
Right.
which requires very strict safeguards for protected health information.
So it's a win-win situation. Better healthcare outcomes through data analysis, plus enhanced patient privacy and compliance with regulations.
Exactly.
It sounds like confidential VMs are a game changer for the healthcare industry. What other industries are benefiting from this technology?
Another area is the financial sector.
Oh, that makes sense. Financial data is probably one of the most sensitive types of data out there.
Absolutely. We're talking bank account details, transaction histories, trading algorithms, proprietary financial models,
Yeah,
all kinds of data that could be incredibly damaging if it fell into the wrong hands.
right. And with the rise of online banking and fintech, more and more of this data is in the cloud, making security even more important.
Exactly. Confidential VMs offer that extra layer of protection,
Okay.
letting financial institutions use the cloud without compromising the security of their data.
So, for example, a bank could use confidential VMs to process transactions, analyze market data, or run risk management algorithms without exposing that data to breaches or unauthorized access.
Precisely. They could even work with other financial institutions on projects that require sharing sensitive data and do it all within the secure environment of confidential VMs.
That's incredible. It's like having a digital vault where financial institutions can safely store, process, and share their most valuable assets.
That's a great analogy.
And it's not just about preventing data breaches. Confidential VMs can also help financial institutions comply with tough regulations.
Yes, definitely.
Like PCI DSS,
Right.
which set standards for protecting cardholder data.
Right.
So once again, we see this theme of enhanced security, improved compliance, and new possibilities, all thanks to confidential VMs.
Yeah.
It's really interesting to see how this technology is being applied in so many different ways.
It is.
Are there any other industries using confidential VMs?
Oh, yeah. They're being used in government defense and even areas like manufacturing and supply chain management.
Wow. Sounds like confidential VMs are becoming more and more common across all sorts of sectors.
They are.
What are some of the key drivers behind this widespread adoption?
Well, one major driver is the growing awareness of just how important data privacy and security are.
Okay.
As we move toward a more data-driven world, businesses and organizations are realizing that protecting their sensitive data is absolutely essential.
You're right. With all the high-profile data breaches happening, it seems like every other day,
Exactly.
businesses are under a lot of pressure to show that they're serious about data security.
For sure. And confidential VMs give them a way to actually enhance their security and gain a competitive advantage by showing their commitment to protecting data.
Yeah, it's like a seal of approval saying, we take your data privacy seriously. We're using the best technology to protect it.
Exactly.
So that's one driver. What's another?
Another big one is that cyber attacks are becoming more and more sophisticated.
Yeah, it seems like every day we hear about new types of malware vulnerabilities and hacking techniques.
It's a constant arms race.
It is.
That's why confidential VMs are so appealing.
Okay.
They offer a much stronger and more proactive way to approach security,
Right.
protecting data at the hardware level,
Right.
and making it much harder for attackers to get in.
So it's like having a security system that's not just reacting to threats, but actively preventing them from happening.
Exactly.
That makes a lot of sense. And I imagine as cyber attacks continue to evolve, we'll see even more adoption of confidential VMs.
It's absolutely.
This has been incredibly insightful.
It
We've gone from understanding the basics of confidential VMs to looking at the different confidential computing technologies, and now to seeing how these technologies are being used in the real world.
It's been quite a journey.
It has. I'm already excited to dive deeper.
Yeah.
But before we do that, I'd like to recap what we've learned so far, just to make sure I've got it all straight.
Okay, let's do a quick recap.
Okay.
We started by talking about the importance of data privacy and security in the cloud,
Right.
and how confidential VMs provide a whole new level of protection by using hardware-based memory encryption.
Exactly. Instead of just encrypting data when it's stored or in transit, confidential VMs encrypt the data while it's actually being used, processed, and manipulated in the computer's memory.
You got it.
Okay. And then we explore the concept of the hypervisor, which is like the landlord of our virtual apartment building in the cloud.
Right.
And we learned that confidential VMs isolate the encryption keys from the hypervisor. So even if the hypervisor is compromised, the data is still protected.
Exactly.
And then we talked about attestation, which is like a certificate of authenticity that verifies the security of the confidential VM environment.
Yep.
Okay. And then we dove into the different confidential computing technologies,
We did.
starting with AMD SEV, which offers a good balance of security performance and features like live migration.
Right.
Then we discussed SEV, SMP, which provides even stronger protection against sophisticated attacks, but might come with a performance trade-off.
Yeah.
And finally, we touched upon Intel TDX, which creates these ultra-secure isolated compartments within VMs called trust domains.
Those are the big ones.
And to wrap it all up, we saw how these confidential VMs are being used in real-world situations like in healthcare and finance, enabling secure data analysis, collaboration, and compliance with regulations.
You got it.
It's clear that confidential VMs are more than just a new technology. They're changing how we think about data security and trust in the cloud.
Couldn't agree more.
This is all really exciting, and I can't wait to learn more, but I think this is a good place to pause for now.
Yeah, we've covered a lot.
We have, and it's a lot to take in.
For sure.
Stay tuned for part 2, where we'll explore even more fascinating aspects of this transformative technology.
Sounds good.
Until then, keep those questions coming, and we'll see you next time.
See you then. Welcome back.
It's great to be continuing our exploration of confidential VMs.
I'm ready to dive back in. We left off talking about real-world applications of confidential VMs.
We did.
And I'm curious to hear more specific examples of how businesses and organizations are using this technology to solve real problems.
Absolutely. Let's look at some concrete examples that showcase just how versatile and impactful confidential VMs can be.
Okay.
One area where we're seeing a lot of innovation is secure data collaboration.
Secure data collaboration. What does that mean?
So imagine a situation where multiple organizations, maybe research institutions or pharmaceutical companies, want to work together on a project.
Okay.
That involves analyzing sensitive data. Okay, so they each have their own data sets that they need to keep confidential.
Yeah.
But they also need to be able to combine and analyze that data together to get valuable insights.
Exactly. Traditionally, this would have been a logistical and security nightmare.
Yeah, I can imagine.
Sharing sensitive data between organizations raises so many concerns about data breaches, privacy violations, and potential misuse.
Right. That makes sense. It would be a major roadblock to collaboration.
And that's where confidential VMs come in.
Okay.
With confidential VMs, these organizations can create a secure, shared environment where they can pool their data without compromising its confidentiality.
So it's like having a virtual meeting room where everyone can bring their sensitive documents, but no one can see what's on the other participants' papers unless they're explicitly given permission.
That's a great analogy.
Yeah.
Each organization can put their data into a confidential VM,
Okay.
and the data stays encrypted throughout the entire analysis process.
Oh, wow.
Only authorized parties with the correct decryption keys can access the decrypted data.
That's impressive. So confidential VMs are enabling a whole new level of trust and collaboration in these data-intensive fields.
They are. One specific example of this is in genomics research.
Genomics research.
Yeah, scientists are using confidential VMs to collaborate on projects that involve analyzing huge amounts of genomic data.
Genomic data, that's the stuff that makes up our DNA, right?
Yeah.
It's really personal and sensitive information.
It is, and with the rise of personalized medicine and gene therapies, the amount of genomic data being generated is exploding.
Well, I can imagine.
Confidential VMs provide a really secure platform for researchers to analyze and share this data without compromising individual privacy.
So researchers from different institutions could combine their genomic data in a confidential VM to study the genetic basis of a disease or to develop new treatments.
Exactly. They can run complex algorithms, compare genetic sequences, and identify potential drug targets, all while keeping that underlying genomic data encrypted and protected.
That's amazing. It sounds like confidential VMs are not just about protecting data, but also about making data collaboration easier and speeding up scientific discovery.
Absolutely. And it's not just genomics research either.
Right.
We're seeing similar things in financial modeling, risk analysis, and even machine learning.
Oh, machine learning. How are confidential VMs being used there?
Well, one of the challenges in machine learning is that it often needs huge amounts of data to train accurate models.
Right. The more data you feed a machine learning algorithm, the better it gets at making predictions and recognizing patterns.
Exactly. But a lot of the time, this data might be sensitive or confidential.
Okay.
For example, a healthcare company might want to train a machine learning model to predict patient outcomes
Okay.
based on medical records.
Right.
But sharing this data with a third-party machine learning provider could raise privacy concerns.
I see. So how do confidential VMs help with this?
Confidential VMs allow the healthcare company to train the machine learning model within a secure, isolated environment. The data stays encrypted the whole time, so it's not exposed to unauthorized access.
So it's like having a machine learning algorithm that can learn from sensitive data without ever actually seeing the sensitive data itself.
That's a great way to put it. It opens up tons of possibilities for machine learning in healthcare finance and cybersecurity, where data privacy is super important.
This is fascinating. It's clear that confidential VMs aren't just some niche technology.
No, they're not.
They're becoming a vital part of our data-driven economy.
Absolutely. And as the need for secure data collaboration and privacy-preserving analytics keeps growing, we can expect confidential VMs to play an even bigger role in the future of computing.
I'm curious, are there any other use cases or examples that you think are especially noteworthy?
There are so many exciting developments happening in this space. One area that I think is super interesting is the use of confidential VMs for multi-party computation.
Multi-party computation, that's a new one for me. What is that?
Multi-party computation, or MPC, is a cryptographic technique that lets multiple parties compute a function over their private inputs without revealing those inputs to each other.
Okay, that sounds complicated. Can you give me an example?
Sure. Let's say you have a group of banks that want to work together to detect fraudulent transactions.
Okay.
They each have their own transaction data that they need to keep confidential,
Right.
but they want to pool their data together to get a more complete picture of fraudulent activity.
So they need a way to analyze their combined data without actually sharing their individual data sets with each other.
Exactly, and that's where MPC comes in.
Okay.
Using MPC techniques, they can jointly compute a function that identifies potential fraud patterns without ever revealing their individual transaction data.
Wait, so they can analyze their combined data without actually seeing each other's data. How is that possible?
It uses some pretty advanced cryptography. Basically, MPC protocols let the parties break the computation into a series of steps that can be performed on encrypted data. Each party only sees the intermediate results of their own computations.
Okay.
And the final result is only revealed after everyone has contributed their encrypted inputs.
So it's like a group of chefs working together to create a dish. But each chef only knows their own ingredients and the steps they need to take, and the final dish is only revealed when all the ingredients are combined.
That's a great analogy. And when you combine MPC with confidential VMs, you get a really powerful platform for secure data collaboration.
Okay.
The confidential VMs provide that secure, isolated environment for running those MPC protocols,
Right.
ensuring that the data stays protected throughout the process.
This is incredible. It sounds like confidential VMs and MPC were made for each other when it comes to privacy-preserving data analysis.
They really are. We're already seeing this technology being used in real-world situations.
Like what?
For instance, some financial institutions are using MPC with confidential VMs to do joint risk assessments
Okay.
or to benchmark their performance against each other without revealing their sensitive financial data.
That's amazing. It's like having a group of competitors working together to improve the industry as a whole, but still protecting their own information.
Exactly.
Yeah.
And this isn't just happening in the financial world either.
Oh, right.
They're seeing it in healthcare, government, and even in areas like advertising and marketing.
Wow, advertising and marketing.
Yeah.
How are confidential VMs being used there?
Well, one example is targeted advertising.
Okay.
Advertisers often use user data to target their ads more effectively.
Right.
But with privacy concerns growing, there is a need for ways to do targeted advertising without compromising user privacy.
So instead of collecting and analyzing user data directly, they could use MPC with confidential VMs to target ads based on like aggregated or anonymized data.
Exactly. They could use MPC to figure out which demographics are most likely to be interested in a certain product without revealing the identities or personal information of those users.
That's a great example of how confidential VMs can help us use data to gain insights while still protecting user privacy. It seems like every time we think we've reached the limit of what confidential VMs can do, we discover even more innovative and transformative applications.
It's a really exciting field to be working in. And as the technology continues to improve and become more widely used, we can expect to see even more creative and impactful ways to use it.
I can't wait to see what the future holds. But for now, I think it's time for us to take a break.
Sounds good.
We've covered a lot of ground, and I want to give our listeners a chance to process all this information before we continue our exploration.
I agree. Let's take a pause and we'll be back soon with more insights into the fascinating world of confidential VMs.
Stay tuned for part 3, where we'll look at the bigger implications of confidential computing and what it means for the future of cloud security.
See you then.
Welcome back to our deep dive on confidential VMs. We've explored what they are, how they work, and why they're so important.
We have.
We've seen how they're being used in the real world to solve real problems.
Yeah, it's been a great discussion.
It has. And now I think it's time to step back a bit and talk about the bigger picture.
Okay.
What does confidential computing mean for the future of cloud security and really for trust in the digital world?
That's a great point. It's about more than just the technical details. It's about changing how we think about data protection and trust in a cloud environment.
Right, because traditionally when we put our data in the cloud, we're placing a lot of trust in the cloud provider.
We are.
We're trusting them to keep our data safe, to protect it from unauthorized access, and to use it responsibly.
Right. And while most cloud providers do take security very seriously, there's always that element of risk.
Yeah, that lingering question of what if?
Exactly. What if their systems are compromised or someone inside the company does something they shouldn't?
It's like giving someone your house keys. You might trust them, but you're still a little worried about what could happen.
That's a perfect analogy.
And that's where confidential computing comes in.
It does.
It's not about getting rid of trust altogether. It's about building a new foundation for trust, one that's based on technology rather than just blind faith.
Exactly. With confidential VMs, we're not just relying on the cloud provider's security measures.
Wow.
We're adding another layer of protection that's separate from the provider's infrastructure and control.
So it's like having your own security system inside the cloud provider's house. So even if someone else has the keys to the front door, your belongings are still safe.
Exactly. Even if the cloud provider systems are breached, the data inside your FIPARANA, confidential VM, is still protected because it's encrypted at the hardware level.
Right.
And the keys to unlock that encryption are stored in that trusted platform module, the TPM,
Right.
which the provider can't access.
So it's like having your own safe inside their house with a lock that only you have the key to.
Exactly. That separation of control and trust is really important.
It is.
It gives users, whether they're individuals, businesses, or government agencies, more control over their data security and privacy in the cloud.
I can see why that would be appealing, especially for organizations dealing with really sensitive data, like healthcare companies, financial institutions, or government agencies.
Absolutely. And as more and more organizations start using confidential computing, I think we'll see a shift in the relationship between cloud providers and their customer.
A shift in power dynamics. How so?
Well, right now, cloud providers have most of the control when it comes to data security.
Right.
They control the infrastructure, the security policies, and access to the data.
But with confidential computing, that power starts to shift back to the users. They
Exactly.
can now enforce their own security policies, control access to their data, and even decide where their data is processed and stored.
They're not at the mercy of the cloud provider's security practices anymore.
Right.
They can create their own secure spaces within the cloud, their own little digital embassies where their data is protected by their own rules.
That's a powerful way to put it.
And as this idea becomes more popular, I think it will lead to a more decentralized cloud ecosystem where power is shared more evenly between providers and users.
So it's not just about better security, it's about creating a more balanced and fair playing field in the cloud.
Exactly. And I think this will have a big impact on innovation.
How so?
Well, when users have more control over their data and more trust in the cloud environment, they're more likely to experiment, to collaborate, and to create new applications and services.
It's like removing the roadblocks for those who were hesitant to use the cloud because of security concerns.
Exactly. It opens up so many possibilities for startups, researchers, and anyone who wants to use the power of the cloud without risking their data privacy.
It creates a space where data can be shared, analyzed, and used in new ways while still protecting privacy and security.
I agree. It's a really exciting time to be working in this field. And as the technology keeps getting better and more widely adopted, I think we'll see even more creative and impactful uses for it.
This has been an amazing conversation. We've covered so much ground, from the technical details of confidential VMs to the broader implications of confidential computing for the future of cloud security, trust, and innovation.
It has been a great conversation.
It really has, and I think this is a good place to wrap up.
I agree.
Any final thoughts before we sign off?
Just a few key takeaways for our listeners.
Okay, I'm listening.
First, confidential computing is a fundamental change in how we think about data security in the cloud. It's about giving users more control over their data.
Right, taking back some of that power.
Exactly. Second, confidential computing is not just about preventing data breaches. It's about making new things possible, making collaboration, innovation, and scientific discovery easier and safer.
And enabling all sorts of amazing things that we haven't even thought of yet.
Exactly. And third, as we embrace this new technology, we need to think about the ethical implications
Right.
and make sure it's used responsibly to create a more trustworthy and equitable digital world.
That's a great point. We need to be mindful of how this powerful technology is used.
Absolutely.
Thank you so much for sharing your expertise and insights with us today.
It's been my pleasure.
And to our listeners, thank you for joining us on this deep dive into confidential VMs.
We hope you learned a lot.
We did too. As always, stay curious, stay informed, and stay secure.
Until next time.